Hello all, welcome to KT Semicon self-paced learning module. In this session, we are going to discuss about implicants in KMAP. So before that, let me share my screen. Now, so there are various implicants in KMAPs, like prime implicants, essential prime implicants, redundant prime implicants, and selective prime implicants. Now, first of all, let us try to understand about prime implicants. So basically, a group of squares or rectangles made up of a bunch of adjacent minterms, which is allowed by the definition of K-maps, are called as prime implicants. That is, all possible groups formed in a K-map is nothing but our prime implicant. Now, let us try to understand what is meant by this prime implicant. Now, let's say if we have a three variable function f of a comma b comma c is equal to sigma m 1 2 3 7. Let's say these are our main terms. First of all, let us try to draw the k-map for this. So this is my k-map. A, B, C, B bar, C bar, B bar, C, B, C, and B, C bar, A bar, and A. 0, 1, 3, 2, 4, 5, 7, 6. Okay. 1, 2, 3, and 7. So I have mapped my implicants over here. Now, what I'm going to do is I'm going to first of all group the possible number of minterms over here. So this is one possible pair with which we can group, and this is one possible group, and this is one possible group. So there are total three prime implicants. So this is one prime implicant, and this is another prime implicant, and this is third one. So total prime implicants over here is three. Okay. So this is how we are going to find out what are the prime implicants. So prime implicant is nothing but the possible number of groups. Now, let's say, let us try to understand about essential prime implicants. Now, what do you mean by an essential prime implicant? So these are the groups that cover at least one minterm that can't be covered by any other prime implicant. So essential prime implicants are those prime implicants that always appear in the final solution. Now, what do I mean by this? Let us say if I'm going to have f of a comma b comma c. Let's say this is my k-map which I'm going to draw, and in this k-map, let's say the minterms are arranged like this: 1, 1, 1, and 1. Okay, let's say these are my minterms, and it is a function. So this is 0, 1, 3, 2, 4, 5, 7, and 6. Okay, so the minterms which I'm going to have is 1, 3, 7, and 6, right? Now, first of all, let us try to group the prime implicants. So this is one prime implicant, and this is another prime implicant, and this is another prime implicant, right? So this is also a prime implicant which I am going to draw. So total, I have three prime implicants in this K-map. Now, what do I mean by this essential prime implicant? So by the definition of your essential prime implicant, so the group that is either going to contain, so the group which is going to contain at least one main term that can't be covered by any other prime implicant. So what do I mean? So in this particular prime implicant, I have two main terms. Now, this main term is not covered by any other group, and this main term is covered by some other group. But this group is having one main term at least which is not covered by another group. So this is termed as essential prime implicant. Now, coming to this group, in this group also, we are going to have two main terms, but this main term is not covered by any other group, and this main term is covered by some other group. But there is at least one main term which is not covered by any other group. So this can also be stated as an essential prime implicant. But coming to this particular group, this group has two minterms, but these two minterms are involved in some other grouping. So this particular group cannot be said as an essential prime implicant. This is referred to as redundant prime implicant. So that is nothing but my essential prime implicant and redundant prime implicant. So the implicants for which each of the minterm is covered by some other essential prime implicants are known as redundant prime implicant, and this prime implicant never appears in the final solution. So we are not going to write down this particular minterm expression in our final solution. Only we are going to include the essential prime implicant solution in our final solution. Now, Coming to our selective prime implicants. Now, what do I mean by selective prime implicants? So the implicants for which are neither essential and nor redundant are known as selective prime implicants. So they are also known as non-essential prime implicants, and they may appear in some solutions or may not appear in other solutions. What do I mean by this? Let's say if I have a simple KMAP like this, and this KMAP is going to have the cells. Let's say this is A, B, C, B bar, C bar, B bar, C, B, C, and B, C bar, and A bar and A. 0, 1, 3, 2, 4, 5, 7, 6. Okay. Now I'm going to have my midterms like this 1, 1, 1, 1, 1. Okay. Now, first of all, let us try to plot the prime implicants. So this is one prime implicant, and this is one more prime implicant, and this is another prime implicant, right? So this is nothing but my prime implicant, and this is one more prime implicant, and these two are also known as essential prime implicants because I have a group, and in this group, what at least there is one min term that is not being shared by another group. So this is also said to an essential prime implicant. Now, coming to this grouping, someone can group in this manner or some other can group in this manner. Okay. So you cannot say this as a redundant prime implicant, but this is an selective prime implicant. So the selective prime implicants which we have here is total 2. And essential prime implicants we have is 2. And redundant prime implicants are 0. So these are nothing but my prime implicants in KMAPs. So that's all about this particular session. Thank you.